Hello, guys. Welcome to another session with Leo. Today, we're going to go through the 0x00C Hello World project. And like I always do, I want to take you through the concepts of the project before we go through the tasks. It is very important to understand the concepts of the project so that when you meet a challenge anywhere, you'll be able to tackle it. So let's take a short time and go through the concepts of C Hello World. So in this project, we are dealing with C Hello World. Let's try and see what the objectives of this project are before we go on. You have to know, by the end of this project, you have to know why C programming is awesome, who invented C. These are some of the objectives. You have to know what printer, puts, and putcar does. What is the official C coding style and how to check your code with Betty style? You have to know what this is too. How to find the right header to include in your source code when using a standard library function. So these are going to be some of your learning objectives for the project. And then there are the requirements as well. So let's go straight into my Evernote and then let's see what we can learn today based on the objectives of the projects that we were given. So let's just try and go through my Evernote in just a few minutes before we tackle the quizzes and the tasks. If you've already gone through the resources and you have a great understanding of this, then you can just go straight to the quizzes and tasks and then see if you can try your hands on them. Now, just by the way, everything you're going to see in this notebook is in my GitHub repository. I've named it Programming Notes. I'm going to leave the link in the description below so that you can access this note in my GitHub. The name of the repository is Programming Notes. I have a whole lot of resources inside that repository, not just C, but Python, JavaScript, and a lot of resources that are going to be of help to you as a software engineer. When you go into that repo, make sure you give me a star, make sure you give me a follow, give me a like, comment on it, and let me know what you think. I'll leave the link in the description below. Thank you. Let's get straight into it. Who invented C? Dennis Ritchie and his buddy Ken Thompson. They did that at Bell Laboratories. You can read this in Google. I mean, there's a wealth of information you can find over there. Who are Dennis Ritchie, Brian Kennedy, and Linus Torvalds? Now, when you research on these guys online, you realize that they are very instrumental guys to the computer science world, and they have made significant contributions to this field. You can read a whole lot about them in my notebook. If you just check out my Evernote with a link in the description below and also in my GitHub. What happens when you type gcc main.c? Now this is where things begin to get more technical. Anytime you are dealing with C and you see the acronym GCC, it simply means GNU's Compiler Collection. Now this is very interesting because it's actually a recursive acronym. Now that means that the first letter of the acronym itself is an acronym. So the G you see over here is an acronym, which means GNU in the GCC. And the GNU itself also means GNU's not Unix. And that's even more interesting because we realize that even the G in the GNU is also another acronym. So the GCC itself means GNU's Compiler Collection. And then the GNU itself also means GNU's not Unix. It's really interesting. Now, the reason why they named it this way is that they're trying to say that the GNU compiler is not Unix. Even though it was built on Unix principles, they're trying to say that this is not Unix, guys. It's just their way of letting you know that their software is kind of special or something like that. Okay, so you can read more about this in my notes. It says that the GCC command looks for the file main.c in the current directory. So now you're about to run a C program, and when you run GCC, it means that it's looking for the source code of your C file. When it finds the source code of your C file, now it's going to check if there are errors in the file. If there are no errors, then now it's going to begin the compilation process of the code. After it compiles the code, it's going to generate another file. Sometimes it's the default name that's given to it is a.out or a.o. But you can actually decide what name you want to give to it. And we are going to understand all these. So don't worry if you are like kind of lost currently. Don't worry at all. We are going to demonstrate for you to see everything, for you to understand everything I'm trying to say. So just follow for now, and then as we proceed, every understanding you seek is going to come to you just keep following. And it says that if there are multiple source files, GCC will compile each file into a separate object file. Then finally, GCC links the object files together to create an executable program. Now this is very important and you're going to understand it. But before we delve into the technicalities, let's understand what is an entry point. Now you must understand that I'm actually going through the learning objectives. So if I come back to my intranet, you realize that everything I'm explaining are the objectives of this project. You can see what is main, what is an entry point, what happens when you type gcc main.c, how do you print text using printer, pushcar. So everything I'm actually showing you in my notes are things I put together concerning the resources, and if you take your time to go through them in a short while, you should understand what this entire C project is about. Now it says that an entry point is a specific location in a program's code where the operating system starts executing the program. That means that if you have a program, the entry point is the exact position in the code where the operating system is going to start running the code. Then one last question, it says that what is main? And main for C programming is the entry point of the program. So having said all that, let's actually try to write a very simple C program to understand everything that we have said up here. We'll write a simple C program and explain the aspects of the program so that we can understand what is C and how do you run a C program. Before we do that, we have to understand what is compilation. So I'm going to go into my terminal and then we'll explain what everything you see over here means. Okay, I'm inside my terminal now. Let's create a file called test.c, and inside that file we are going to create a simple C program to understand the aspects of a very simple C program. So I'm just going to come into my notes and copy this program and then explain to you what everything means. Let's just paste it here. Okay guys, what you see over here is the simplest of C programs that you can write, and this program prints out hello world. As usual, we always want to print out hello world when we are starting a new programming language. Now this is the structure of a very simple C language, C program, and even if you are writing very complex programming languages or codes, you're going to follow this same structure. So let us understand what we are seeing over here. The first thing we see over here is include stdio.h. What does this mean? This is known as a header file. Now in every C program, you need to start by importing your header file, and this means you are including the standard input and output. And what does this mean? When you read my notes, it says that in C program, this syntax hashtag or pound include the standard input output.h is a preprocessor directive that tells the compiler to include the standard input output library in the program. It provides the declarations for functions like printf, scanf, whatever, all these and many others that are used to perform input or output operations in a C program. Guys, don't get confused at all. Basically, what this is saying is that this syntax include standard input output.h allows your code or your program to use other functions that receive input or that display output in your code. So without this header file declaration, your code cannot receive input, which means that it cannot even work. Neither can it display output. So this function you see over here, hashtag include standard input output, is what allows other functions that receive input or display input to even work in the first place. Now it says that you are able to use these functions in your program without having to write their declarations yourself, and this will save you time and effort. So back to our C program. For every C program you are going to write, this is the first thing you have to write out. That syntax is very important. You want to take note. Now the next thing you want to do is to declare a function known as main. Now once again, when we go into my notes, it says that this is the starting point of every C program. So when you are writing a C program, after you have declared your standard input and output, now you want to declare a main function, and that is going to be the entry point of your program. Remember that we spoke about the entry point. That means that is where the operating system will start executing your code. Your code execution is going to start from the main function. That is the next thing you want to write out when writing a C program. as you advance in the language, you're going to realize that this thing shows up every time. So don't worry if you're not familiar with it right now. Just accept it, appreciate it, that okay, when I'm writing a C program, the first thing I have to do is to include standard input output. Then the next thing I have to do is to declare my main function. Just like accept it, even though you may not understand it yet. Then the next thing you want to do is to now create a code block, and then what the program contains. This time around, we want to print hello world, and this printf function is what prints out output. There are many others, such as puts. Let's just have a look at them. So as you can see, apart from the printf, there is also puts, which also prints out text, and there's also putchar. And all these are ways of outputting text in C programming. So the printf you see over here is one of the ways of outputting text, and this time around we want to print out hello world. The \n, what you see over here, simply means is going to create a new line. This means a new line after the code has run. Then the return 0 you see over here is connected to this function we declared over here. Remember that this int over here is an integer, it's a data type. We'll understand that later. So this int you see over here, we are declaring a function with an integer as a data type. So that means that when it's done, it has to return an integer. If it returns anything apart from 0, it means the code did not function properly. So we must always return 0. This is the basic syntax of a very simple C program. Like I always say, don't worry if you don't get everything completely yet. As we proceed, you are going to start getting very familiar with the concepts. So we have written our first C program. Let's exit our editor and then ls. So you can see that we created a file called test.c. Now I need you to pay particular attention here because I'm about to take you into very important concepts in C programming. The file we created, in which we wrote a simple C code, is known as test.c. Alright, so if I list the content of test.c, you realize that this is what we wrote. So this is the content of our code, as we already know. Let me quit from here. Great. Okay, so now that we have created our C program, how do we run it? How do we compile it? What does it mean to compile in C? What does it mean to interpret? Now, before we explain that, let's check out my notes. Now, inside my notes, I talk about what is programming. There are various kinds of programming language. Programming is simply a way of humans communicating to a computer. It's as simple as that, okay? And then there are various kinds of programming languages that humans can use to speak to a computer. Now, there are categories of programming languages. There is machine language, procedural language, scripting languages, etc. Now, C is part of a language that is known as a procedural language. Now, that means that they go through a series of procedures before a program is executed. All right. Now, one of the processes is the compilation process. So the procedural languages, one of the processes they go through is that they are compiled before the program is run. What does this mean? To compile a program refers to the act of converting programs written in high-level programming language, which is understandable and written by humans, into a low-level binary language understood by only the computer. So the programmer, who is a human, writes in a high-level programming language. Then what the compiler does is that it now translates the code into a low-level binary code that the computer can read and understand. Remember that computers understand only zeros and ones. So let's say the code that we wrote in our C program. When you give the code to the computer is not going to understand the thing that we wrote in here. Include std, your standard input output, all this. The computer is not going to understand this. If you give this to the computer, it's going to fail because computers only read zeros and ones. So we'll have to compile the code and then allow the compiler to translate the language into a binary code that the computer can relate with. That is what we're going to learn how to do right now. Okay, so this is how you compile a file in C. You just type out GCC and the file name. So let's go into our terminal again. Let me clear my screen. We have space to work with. When I ls, you realize that we only have the file we created with our simple C program. I'm going to compile by typing GCC and then the name of the file. And now when I ls, see what happens. You realize that a new file has been created known as a.out. Now take note that I did not create this file. The only file we created to write our C program is test.c. But when we compile the program by typing gcc and the name of the file, suddenly a new file has been created known as a.out. What is this file? This file is what is known as an executable file. This is a file that the computer understands because it contains binary code. We are going to learn the process of how the computer comes about this file right now. But then let us try and run this code by typing ./a.out. Now when we run this code, realize that it runs hello world, which is the content of our C program that we wrote. This is what is known as an executable file. So what the compiler did is that it changed our high level programming code written by you and I, which is a human language, into a machine language. So let us try and see the content of the a.out file and see what is inside. So I'm going to less a.out. Now it says that a.out may be a binary file. Do we want to see it anyway? If you want to see it, just type y and then opens it. Guys, look at this. This is just serious information that I cannot make any sense of. This is what an executable file looks like. And interestingly, this is what a computer understands. It makes no sense to you and I. However, this is the code that the computer understands. Now let me exit. So what is happening here is that when you write a C program, your compiler now changes it to a binary executable file that your computer can read. And when you execute the file, just like we did over here, it ran out the output of the file. How did the computer do this? Let's take this one step after the other to understand. Now, here we are in my notes again. Before that executable file with the binary code is created, the computer goes through 4 main processes. They are pre-processing, compilation, assembly, and linking. We're going to understand what these mean as we proceed. To create a pre-processed file, this is the command that you use. All right, so let's try and go and create. You know, when you compile your file, the computer has already gone through all these processes, but you do not see it. All that happens is that this happens under the hood, and then your executable file is just created at this level. But all this process happens under the hood, which you do not know of. But it occurs, and then suddenly you have a new file, which is an executable file with binary code. But we are going to understand the process that leads to that. So to create the pre-processed file, the command that you use for that is gcc with extension -e. So let's try that out. I'll clear my screen, then we are going to try that out. So we are going to compile with gcc with extension -e, capital E, very case sensitive. And then the file that we are pre-processing is test.c, that is our C file. Then you now want to use the flag -o, small o. This means that we want to output our file to a specific file. So now we are deciding that, okay, take the output to this file that I'm about to create or give you. Now let's output the file to test.e. Okay, now I enter. All right, let me ls and let's see what happens. Suddenly a new file called test.e has been created. Let's try and see the content of this file. Let me less this file test.e. Look at this. Suddenly a pre-processed file has been created, and our simple hello world program is giving us all this information. But this is not for you to understand, it's for the computer. Let me quit out of here. So we understand the pre-processing stage. The next thing that the computer does is the compilation. All right, and the command to compile a file is gcc-s and then the file name. Then you can output it to any file name that you want. So let's try that out too. So gcc-s, then the file we are working with is test.c. Then we want to output it to a file known as, let's say, test.s. You can choose any file name, by the way. Then we enter. Now let me ls, and suddenly we can see that our file test.s has been created. Let's just see the content of this file. Guys, look at this. Now we have a mnemonic code that has been generated. So we see that a lot goes on with C programming. And if we look into my notes right now, I've explained some things going on here. At the pre-processing stage, what happens is that comments are removed, header files are included, and then it replaces it with macro. It replaces the macro name with code. You understand what that means right now? And then at the compilation stage, a mnemonic code is generated, and that is what we just did. This is the mnemonic code. All right, now let's just try to assemble, and then let's see what happens. The command to do that is gcc-c and then the file name. So let's exit this, and then let's try and assemble. gcc-c, the file we are working with is test.c, and we want to output it to a file called, what name did I give it? Test.o. Okay, you can choose any name. Now let's ls and see. We have a new file here called test.o. Let's see the content of this file, test.o. Now you realize that we are back to where we came from. It says that it's a binary file. Do we want to see it? Then you type y, meaning yes. This is the executable file that was created at the initial stage when we compiled. It contains code that doesn't make sense to humans. Okay, you realize that the process of running a C program is first the pre-processing. Let me make this easy for you. I have the an acronym that I use for these 4 stages of running a C program. They are BCAL, BCAL. All right, you can keep that in your mind, BCAL. So this is the pre-processing, compilation, assembly, and linking. Now at the assembly stage, that is where the binary code is created that the machine can read and understand. And when you are done, all you have to do is to link the file. Now the linking of the file is just as simple as running the code. So as a programmer, you don't have to try all these two before you get to the linking stage. You can simply compile by typing gcc and then the file name, and it compiles it straight to the linking stage. But I just wanted to give you an understanding of what happens at the background before a C program is run, so that you know that, okay, so when I run my C program, it is pre-processed, it is compiled, it is assembled, then it's finally linked. So let's try and link it to a certain output file, and then let's see what program is run. So to do that, we just gcc, sorry, small cases, we gcc our file name, which is test.c. Now the .c means that it's a C file. That's the extension for every C file. And then the continuation, we are outputting it to, so let's output this file to test.executable. Now let's ls, and as you can see, we have a new file created called test.executable. Let us try and run, or rather, let's just try and let's try and run this file and see what happens. To run it, you use // and then the file name test.executable, and let's see what happens. Boom, hello world. So you see, we went through all these processes and came to the linking stage, and when we run our output file, we run the program that you wrote, hello world. This is the simple foundation of every C program that you are ever going to write in your life. This is the fundamentals of every C program. Okay guys, so having laid this foundation, let us go and understand what it means to code with a Betty style code. This means that your code has to be compliant with what is known as Betty. Who is Betty? To check your C code against a Linux kernel coding style, you can use a tool called Betty style. Betty style is a script that checks your code for compliance with a Linux kernel coding style and provides suggestions for improvement. Now, if you are using the ALX terminal or the intranet, your sandbox, the Betty style guide has already been installed in it, so you don't have to install Betty. But if you are coding on your local computer, then you need to install Betty on your local computer. Because we don't want this video to be too long, I already have a video on how to install Betty and how to make your code compliant to Betty. So you want to watch that video and then make sure that you have installed Betty on your local system. However, like I said, if you are using your sandbox, then you don't have to install Betty. But if you are running C codes on your local machine, then you have to install the Betty style guide. And in that video, I ran you through the installation process. Okay, so let's go learn about variables, and then we'll now move straight to the answering of the tasks and the questions. Okay, so what are variables? Now, in every programming language, there are variables. Okay, a variable is a name given to a memory location inside our computer where we can store data. So basically, you are creating a shell. let's think of a variable as a basket, and you can put items in a basket. So whatever you declare a variable, you have created a basket, and now you can keep items inside that container or that basket or that shell. The syntax to declare a variable in C is that you declare the data type, then the name of the variable. Then you can also choose to assign a value to the variable. We'll come to the naming conventions of variables soon, but let's skip that for now. So this is the way a variable is declared. So this is int, standing for an integer data type, and then we are calling the variable age. Or you can just go ahead and declare the variable as age equals, then you assign a value to the variable. And the third way you can do that is to indicate the data type, the name of the variable, then you assign a value to the variable. So int age equals 25. So according to the format of C programming that we learned, let's put it in that structure. Let's create a variable called age and put it in the C coding structure. Remember, I told you the first thing you have to do is to declare your header, include standard input and output, and I've already explained what this means. Then you call your main function. Your main function, like I said, is an integer function, for which reason you have to return 0 when you are done. As for this format, just memorize it in your head. Then now we want to declare a variable called age. Definitely it's going to be an integer. And remember, I told you that your entire code must be inside the main function. So you open a code block over here, and then you close it over here. So everything you're going to code in C stays inside the main function. So we declare a variable. The data type is integer. The age is the name of the variable. This is the value we are assigning to the variable. Now, for us to print a variable, there is something very important we have to know, which is known as the format specifier. There are various data types in every programming language, but for C, before you print out a data type, you have to indicate it with a format specifier. And for printing out integers, the format specifier is %d. So you cannot just come and say printf, then you bring the name of the variable, which is age. You have to first bring the format specifier in quotation marks, then you bring the name of the variable. So let's move ahead and talk about format specifiers. We'll come back and continue. So like I said, there are various data types, and then these are the sizes of the data types. There is char, which is 1 byte. There is int, which is 4 bytes. There is long, which is 8 bytes, and then a lot more. Alright, so these are the format specifiers. There are a bunch of them, but these are the most important you need for now. But you can go online and then find out the syntax for declaring various format specifiers, and then which data type that they relate to. So for integer is %d, which we've already seen. For a double is %lf. A double is also another data type for declaring decimals, just that it has more size, it has a higher size than a float, because a float is also another data type for declaring decimals. And the format specifier for that is %f. For a double is %lf, and for a character is %c. Alright, so now that we understand format specifiers, let's go see them in action and see how they are used. We have already seen that when you want to print out an integer, you use the %d format specifier. Now, one thing you can do is that you can assign a new value to the same variable. A variable is called a variable. Something that's variable means it changes. Alright, so the reason why they are called variables is that they are subject to change. I can assign a value, let's say 25, to age. Then I can print it out, age %d age. Now, in the next line of code, I can just come and assign another value to the same variable. Now you realize that when I print the variable out on the terminal, it is going to print the new value that I assigned to it. Okay, then like I said, if you want to print on a new line, this is the syntax for printing on a new line. So let's talk about naming conventions of variables. Okay, you cannot create a variable name with space in between. So I cannot create a variable and call it first number. This is a wrong way of creating variables. 2, you cannot start variable names with numbers. So I cannot start a variable and call it 1 variable. This is very wrong. You cannot create a variable like this. The third one, you cannot use certain words as variable names. For instance, I cannot call a variable if, because there is something called a reserved word, and reserved words cannot be used as variables. You want to know the list of reserved words? They are very simple to come by, and there are a lot. You cannot memorize all of them, so you just have to make reference to them online. And even if you use a reserved word, the code and system itself will tell you that you have used a reserved word. For instance, I cannot declare a variable and call it car, because car is a reserved word in C programming, and it goes on and on and on. Then one thing to do is to use descriptive variables. So let's say if I'm assigning a variable to somebody's age, I can use a descriptive variable age. Or if I'm assigning a variable to someone's first name, I have to make it very descriptive. Then it is good to use camel case lettering for variables. So for instance, for the variable I just declared first name, the camel case is to use a small letter for the first word and then a capital letter for the second. This is a camel case way of declaring variables. Now, for this variable, we realize that I used an underscore. So using underscores is one of the best ways of declaring variable names. Then the camel case is also another effective way of declaring variable names. You want to take note of that. Now, I think we've done enough. There's so much more to learn. So let's get straight to the task and then see what we can do with the knowledge that we have gathered. Our first quiz question says that which command can be used to compile a C source file? And we already went through the resources and realized that it is the GNU's compiler collection, which is GCC. It's an acronym. In which category belongs the C programming language? Of course, we spoke about interpreted languages, we spoke about procedural languages, we spoke about compiled languages, and we spoke about scripted languages. I realized that C falls under the category of compiled languages. What is a common extension for a C header file? And it is the .h, as we have already seen. What is a common extension for a C source file? I told you that for every C source file you're writing, the extension is .c. What are the different steps to form an executable file from C source code? So, like I said, you can use the acronym PCAL. Okay, we went through these in details. We use the code for preprocessing, compilation, assembly, and linking. If you went through the video info, you should be able to answer that. Which of the following are both valid comment syntaxes in ANSI and Betty compliant? Alright, so you realize that if you watch the video on Betty, installation of Betty, this is what I use for the comment. And then you can also do a multi-line comment. So this is an inline comment. If you use this, even though it's also valid, Betty is not going to agree with you. It's not compliant with Betty. That's the first one. But this is compliant with Betty as an inline comment. And then this is also compliant with Betty as a multi-line comment. But sometimes Betty requires that you use 2 asterisks for the first line. For instance, let me go into my terminal. Let me less test.c, which is a C source code file. And this is a comment you see right over here. So as you can see, I have 2 asterisks, and then this is a multi-line comment. All right. Okay. So to the task. Write a script that runs a C file through the preprocessor and save the result into another file. The C file name will be saved in the variable this. The output should be saved in the file C. Guys, if you took your time to go through the video, this should be a very easy thing to do. However, before you answer your questions, you first want to go into your GitHub repository and create a repo called ALX low level programming. Now at this stage, creating a repository shouldn't be a very hard thing for you. Just go into your GitHub, create that repository, clone it into your local with your access token. Don't forget that, clone it into your sandbox or your terminal with your access token. If you don't know how to do that, we have already done several videos on that. You can just take your time and go through that. When you have cloned your repository to your intranet, now you want to create a directory called 0x00 hello world. Create that directory inside this, which means that you have to cd into this first and then create this directory. And when you are done creating a directory, cd into it. And then when you are done, create a readme file. Create a readme file. These are very important processes. Great. When you have done all that, now you can come to Zero Preprocessor. Now let's do that task. The reason why I didn't go through all the steps of creating the repository, cd into the directory, creating a readme is because by now I expect that you should be able to do that. Okay, so let's go straight to answering the first task. You want to VI the file, then remember it says we are writing a script. So to write that script, what you do is that you bring your shebang, which is a bin bash. Okay, then we are going to pre-process this file, and the command to do that, as I already explained in my Evernote, is that you first call out the GCC because we are about to pre-process. Whether you want to pre-process, compile, assemble, or link, the command to do that is GCC. Very important. And then the question says that we are writing a script that runs a C file through the preprocessor. We are going to output it into another file because the C file name will be saved in a variable this, and then the output will be saved in C. So if you look at this code over here, now we are calling the file. This is the file that we're going to pre-process, and then the -e is a command for pre-processing. Then we output it to another file called C. When you run this command, a new file will be created called C. This is exactly what we explained over here. So for pre-processing, the flag is -E, the file name, and you output it to the name of this file. That's exactly what we see over here. Okay, to the second question, compiler. Write a script that compiles a C file but does not link. Okay, the C file name will be saved into the variable this. The output file should be named the same as the C file, but with extension .o instead of .c. Example, if C file is main.c, the output file should be main.o. And I think this is pretty straight to the point. So you want to VI the name of your file. Does this look familiar to you? That's what we actually encountered when we were explaining the assembly process. So let's create this file. Let's go into our terminal and VI the name of the file. Let me exit VI, and I VI the name of my second file. Okay, does this look familiar to you guys? GCC-c and the name of the file. Let's go into my Evernote and then see that. Now you remember that to generate that binary code that we saw, the flag is -c, then you bring the file name. Then this is the output, and it's outputting it to test.o. Well, you'll be wondering, why is it that over here we didn't indicate the output file? Now the reason is that when you are assembling a code and you don't indicate the output file, it creates a default one with an extension .o. The others will say .out. All right, but this file is created by default, so that's how come it wasn't added here. Okay, so to the third task, assembler. So you want to go VI the name of your file, write a script that generates the assembly code of a C code and save it in an output file. The C file name will be saved in the variable this. The output file should be named the same as the C file, but with the extension .s instead of .c. Okay, so let's go do that. Let's go VI the name of our file. Like I said, GCC-s. As you can see over here, that is the compilation process. That's what generates the mnemonic code. So GCC-s in the name of your file. 3. Write a script that compiles a C file and creates an executable named C is fun. You want to VI the name of your file. Okay, over here what is happening is that you now want to compile your file. Now the GCC comes with no flag. Alright, so you just enter the name of your file and output it to the file name that was given, which is C is fun. Then you exit VI. 4. Write a C program that prints exactly this, followed by a new line. Use the function puts. You are not allowed to use printf. Remember I told you that I showed you 3 ways by which you can print stuff in C. And if you use a print function and you want a new line, it means you have to use the \n. However, if you use the puts function, then you don't have to indicate because this one automatically takes it to a new line. So let's go try it out. For puts a C. We add the name of your file. Okay, so remember that we are about to code, and our code has to be compliant with the Betty style guide. So the first thing, you want to enter your header file, which is include standard input and output.h, your header file. Then give a comment. Your main is going to print a line of code using puts. All right, then you're always going to return 0. Okay, now after the comment section, then now come and declare the function with the int and your main and void. This is really important. And now your block of code is going to be inside this main function. The function we are using to print is put. So enter the put. Now you need to escape the character quotation mark, or else the code is going to get confused. Take note that there's a quotation mark at the beginning of the code. So you're going to use this backslash to escape this character. Now what does it mean to escape characters? It means you don't want the program to run it like it's part of the syntax. It's to just add it to the string. It's as simple as that. So you escape this character, and then now you enter the string that you were given, and then you return 0 in parentheses. If you don't add parentheses, Betty is going to flag you. You want to do it exactly as you see it. Then escape-pi. Write a C program that prints exactly with proper grammar, but the outcome is a piece of art, followed by a new line. This time around, we are using printf. You are not allowed to use the function put. Your program should return 0. Your program should compile without warning using the -war gcc. Okay. You just VI the name of your file. Okay. Now, I think you're beginning to get familiar with this structure. The more you code, the more you get familiar with this. Your header file, your comment, your int main function, which is void, the printf, the string that you were given. Remember that because we are, let me just minimize this a little so that we see it all. I think I minimized it a bit too much. Because we are using the printf function, now if we want a new line, we have to \n. Okay, if we were using puts, there wouldn't be a need for this. Okay, so we return 0 parentheses. Okay, so now to task 6. Write a program that prints the size of various types on the computer. It is compiled and run on. Okay, you should produce the exact same output as in the example. Warnings are allowed. The program should return 0 as usual. You might have to install this on your Linux to test this GCC option. No problem. So okay, let's VI the name of the file. Don't worry about what you see here. The code works just fine. Okay, so just VI the name of your file. All right. Then, as usual, you want to declare your header file, standard input output. Enter your comments. Declare your main function. Then, now you're going to assign variables. Okay. Instead of having these the way we have them over here, let's just, instead of using their names, I intentionally did them this way just so that you have a fair idea of what exactly we are declaring. But then let's use characters for them. So the character we are using C, for the integer we are using I, and then for the long let's use L, and for the long let's use ALL, just so that you know exactly what we're talking about. That's a reserved word, so let's use LL. Then for a float, let's just use F. Okay, and when you're done, you have to come and print F, all that, and we are using the format specifier LU. This is for the unsigned long. So the unsigned long works for integers, it works for long, works for long. So you realize that we are using the %LU format specifier for most of them. That's because it actually works for most of the data types. So you print F the size of car. This is just like something you want to appear in your terminal. Then you bring the format specifier, and then we are printing the size of the data type. So what we want to use is the size of function. This is very important. So let's declare the variables in here. Okay, then when we are done, we return 0. Escape-pi. Now let's move to the advanced task. Write a script that generates assembly code Intel syntax of a C code and save it in an output file. Okay.
So let's explain what this means. The GCC is the command for invoking the GCC compiler, as we already know. Then the -s flag instructs the GCC to generate an assembly code instead of an object code on an executable file. Okay. Then the MASM equals to Intel specifies the output assembly code to use the Intel syntax for the x86 architecture. Okay, don't worry if you don't understand it. It's just a kind of syntax for generating an assembly code with the Intel syntax. You should just know that this is how it works. Okay. Then, as we already know, the $C file is just a placeholder that represents the name of the source file that we want to compile. And it's as simple as that.
Just copy it to your code, and then let's move to the next task. Okay, now to the final task. Write a C program that prints exactly this string, followed by a new line to the standard error, which means that the code should exit with an error, right? You're not allowed to use any functions listed in the name section of the man3 printf or man3 puts, which means that now we cannot use this function, and neither can we use putCal because it's not just a character. Since our program is returning 1, we are dealing with an error. Okay, so let's go. Now you want to VI the name of your file. Like I said, don't worry about this, the code works just fine. Okay, then let's copy, VI the name of our file. What do we have here? Okay, so in this code you realize that 2 standard libraries have been included. Okay, we have the usual standard input and output library. We know what that is, and then now we have a new one. This stands for Unix standard. Okay, UNISTD.h. So because we are not going to use the puts function, we are not going to use printf. That means that we have to import a new library because we have to use a new write function over here to print this string. That is why we needed to import this library. So as usual, to be compliant to Betty, enter your comments just as you see it here. Then call your main function and use the write function, enter the string and return 1 because we are looking for an error output. That's it. Okay. Now, when you are done with all these, you are not done. Remember that some of your files were scripts. Okay. I think the first 4 tasks were asked to write a script. Great. You see, write a script. So some of the tasks actually indicated that it was a script we were writing. That's why we use the shebang. Now, since we're writing scripts, then you should know that we have to change the file to executable mode. So u+x, and we use asterisk, change everything to executable mode. And then when we are done, we revert our readme from being an executable mode. You can actually revert those files that were not scripts to executable mode. Some of them were just C programs, so they don't necessarily have to be executable. But you don't have to worry about that. Just change everything to executable, and then revert your readme's permission, and then you're done. You can git add, git commit, -m, enter your commit message, answer all tasks. You commit it to GitHub. I think I misspelled the commit. Alright, so I used 3 M's instead of 2. So git commit. You already know what to do at this stage. I think you don't really need me anymore at this stage. So you just go ahead and give a commit message of your choice. Alright. Then I've already done this, so I don't have to worry about what comes up. When you're done, git push. Okay. Don't worry about mine. Then when you're done, now come back and check all your codes. You should be good to go. Thank you guys for watching today. Like I always say, go ahead and subscribe to my channel. Hit the notification bell so that you do not miss the future videos that I'm going to release. I'm actually going to work on an entire course on learning C. So you want to stick. This was just to help you go through the project in record time. So this is not actually a lesson about C. This is just to help you just get familiar with the project. Happy coding.